This is a universal testing machine made by Instron. So it basically allows us to measure the firmness of different fruit and vegetables. And that's one variable that we use to assess quality. Consumers use visual appearance, flavour, as well as texture to assess the quality of a product. So for example, the crunchiness of an apple to the ripeness of a tomato. So this is what we're trying to replicate with the Instron, but it's slightly more sophisticated and there's better control, and it allows us to have objective measurements so that we can do statistical analysis. So this piece of equipment is used by lots of different sectors to measure a variety of different materials, such as textiles to plastics. But in crop research, because of its size, it's a bit awkward to take into the field, so it'll probably be research groups that would mainly use this. But there are smaller, more portable versions of this, such as penetrometers, which growers can use in the field to measure the firmness of their crops. And this allows them to check if they're ready for harvest, for example. But unlike the Instron, penetrometer doesn't give us much information. The Instron, we can assess the changes in firmness throughout a particular storage period, along with other quality variables. So by assessing the quality of a particular crop, we can determine the efficacy of different treatments on maintaining quality or extending storage life compared to controls. I think there is a lot of interest in food research at the moment, particularly around food waste. There's a lot of research projects, particularly in plant science, where we're trying to come up with new treatments to extend the storage life of crops and also maintain the quality so that when it reaches the consumer, they are of a decent quality. There's 2 MSc courses within agri-food that this would be relevant to. So this is the Future Food Sustainability MSc and the Food Systems and Management MSc. So students from both of these courses will be allowed to gain hands-on experience operating, setting up and developing new methods on the Instron. Fundamentally, the Instron works by measuring the response of a food product when subjected to a particular force, such as cutting, shearing or compression. So this response is shown as a force deformation curve. So we can calculate the energy required to cut or penetrate the surface of the crop, and this is shown by the slope. Or we can determine the maximum force at the point where the surface breaks, and this is the maximum force here. So we have different probes depending on the type of crops that we are measuring. So for example, with this mini cucumber, we would use a small cylindrical probe for compression analysis, whereas for example an asparagus spear, we have attached a blade to this probe here, and this calculates the energy required to cut the asparagus spear, similar to a consumer using a knife at home. And depending on the crop that we're assessing, we can adjust the speed that the crosshead approaches the crop and also the speed at which it penetrates through. We can use literature to determine the method that we use for assessing the firmness, or if it hasn't been reported before, this is where we would develop our own methods. So this is a uni-axle machine, which means it's got a single column, so this bit here. We've got the load cell here, which will measure the force that's actually being applied. And you've got the crosshead here, which is where you attach the different probes. And you've got your platform, which is where you place your particular crop. You've also got a panel here where you can move the instrument up and down. But we mainly do the control of the instrument using the computer. If the blade cuts through for example, the asparagus spear really smoothly with less force, that's good because that shows good quality spear, probably fresh. Whereas if you need more energy, as you find as a spear is stored, this means the spear is getting tougher. With a research project that was done recently, they were measuring the firmness of avocados during storage. but they were also using another piece of equipment at the same time, so LDV, laser Doppler vibrometer. So with our type of research in post-harvest, we do a lot of destructive analysis, and this is also replicated on farms to check the quality. But ideally, it would be good if we can have a non-destructive method. So they were correlating the results with the Instron to this LDV method, which just uses a little hammer to see the vibrations. And again, that can tell them the texture or the quality of the avocado. So that's been in a recently published paper.